Magnifico Reitor, Senhor representante do Presidente do Conselho Geral, Senhor Diretor da Faculdade de Ciências e Tecnologia, Senhoras e Senhores Doutores da Faculdade de Ciências, Senhores Doutores, caros estudantes, restante comunidade acadêmica, senhoras e senhores convidados, minhas senhoras e minhos senhores. Sinto-me profundamente honrado, grato e feliz por estar aqui hoje. Espero sinceramente que todos os presentes disfrutam desta ceremonia tanto quanto a minha família e eu. Receber o título de Doutor Honoris Causa de das mais antigas e prestigiadas universidades do mundo é marco inesquecível na vida de qualquer pessoa. E a minha gratidão por me concederem esta distinção é imensa. Como talvez consigam perceber, ainda falo pouco de português, que aprendi aos 19 anos. Depois de concluir o ensino médio em Aachen, na Alemanha, tive o privilégio de estijar no Brasil. Foi lá que tive a maravilhosa oportunidade de vislumbrar a fascinante cultura lusofona. Contudo, para não pôr à prova a vossa paciência, irei agora continuar em inglês. It is often said that we live in the most interesting of times, a phrase so common it borders on cliché. Yet, by some objective measures, it has never been more true. The defining characteristic of our universe appears to be the evolution of increasingly complex information processing systems, an evolution that is progressing at an exponential rate. We are, it seems, approaching an information processing singularity. Consider the grand timeline of our planet. For most of its 4.5 billion year history, Earth was a world of inorganic matter, processing information in the languages of physics and chemistry. Then, a spark, the first organic molecules leading to life. From single-celled organisms already vastly more complex than rock, water, or air, evolution progressed to multicellular life, and eventually, around 6 million years ago, to humans. Our species was distinguished by an unprecedented ability to store, process, and transmit information. Yet, what took millions of years to develop, we began to replicate and accelerate even further with technology. Merely a century ago, the first electronic computing machines were developed. Their capabilities have improved exponentially since. So much so that today's AI systems are beginning to master the very exams set by revered institutions like this one, the venerable University of Coimbra. In a way, this continues the legacy cultivated in these very walls. I'm reminded of the great 16th century mathematician Pedro Nunes, who devised new instruments to process information to navigate the globe. He was already building tools to augment human understanding. We are simply continuing that ancient quest. On the future horizon, quantum computers promise another leap, offering to accelerate certain tasks at a double exponential rate, a velocity of progress that is almost beyond human comprehension. This raises existential questions. What do we tell ourselves about this development? More importantly, what do we tell our children? Is this game over for humanity? Approaching this singularity will undoubtedly be a wild ride. Even leading AI experts now hesitate to make predictions beyond a 3-year time horizon. Despite this uncertainty, I remain an optimist, and I offer 3 thoughts. First, my advice to students, including my own 2 sons, is this: learn relentlessly. In an age of answers generated by AI, our greatest value will lie in our ability to ask incisive questions. This is how we will leverage the immense power of AI. Second, we must remember the profound mysteries of the human mind that remain unsolved. While we can define and test for intelligence, we have made little progress in understanding consciousness, the subjective first-person experience of existence. No field, not physics, not computer science, nor neurobiology, can yet offer an agreed-upon model of what constitutes conscious experience, or definitely answer the age-old question of whether we possess agency or free will. Third, we must view AI as the next technology for human augmentation. We have always used technology to extend our natural abilities. Machines strengthened our muscles. Telecommunications extended the reach of our voice, and aircraft gave us the gift of flight. We must now perform a similar judo move with AI, using its power to amplify our intellect and creativity. To resist the universe's apparent trajectory towards greater information complexity is likely futile. To harness it is our greatest opportunity. Imagine, for example, using quantum AI to design nuclear fusion reactors or to model proteins with such precision that we defeat the diseases that have plagued us for centuries. Finally, let us take note that all information needs to be represented by physical means. An idea is written on paper. My words reach you as sound waves. Your digital photos exist within electrical circuits. Ultimately, it is therefore the laws of physics that govern what information processing is possible. By understanding and harnessing these fundamental laws, we become not just spectators, but active participants in this grand cosmic game. It is the only game there is, and it is our privilege to play it.
Senhor Diretor da Faculdade de Ciências e Tecnologia, Senhoras e Senhores Doutores da Faculdade de Ciências e Tecnologia, Senhoras e Senhores Diretores, Senhoras e Senhores Doutores, caras e caros estudantes, restante comunidade académica, Senhoras e Senhores convidados, minhas senhoras e meus senhores. Acabamos de percorrer a Via Latina. Que imediatamente nos remete para a universalidade deste espaço e da ciência que nele se cultiva, traduzida numa linguagem universalmente compreendida por todos os que se dedicam ao conhecimento. Segundo a grande tradição académica deste espaço, no seu mais profundo sentido teleológico, prosseguirei assim, utilizando o código linguístico de origem anglo-saxónica, que desempenha na atualidade as vezes do latim. It's a great honor and a proud moment for the University of Coimbra to gather here today to recognize a truly exceptional figure in science and technology. In this historic setting, within one of the oldest universities in the world, we award the title of Doctor Honoris Causa to Dr. Hartmut Neven, Vice-President of Google and founding director of its Quantum Artificial Intelligence Laboratory. Dr. Hartmut Neven is accompanied by Dr. Paulo Marques, and my colleague, Dr. Gabriel Falcão, is responsible for presenting his career in return. However, I would like to emphasize the profound honor that the University of Coimbra has in welcoming Dr. Paulo Marques today as the presenter of Dr. Hartmut Neven in this doctoral cloister. Dr. Paulo Marques is the CTO and co-founder of the technology company Pixai, an unicorn company that prevents fraud with machine learning and big data methods, born in the Department of Computer Engineering of the Faculty of Science and Technology of the University of Coimbra. This award is much more than a formal gesture. It's a sincere recognition of a person whose work has expanded the limits of what humanity can achieve. It also reflects the values that define our university. A commitment to knowledge, to science curiosity, and to serving society through discovery. Let us begin by recognizing the tradition Dr. Neven is joining today. In the course of the Honoris Causa degrees awarded by the Faculty of Sciences and Technology, during the last century, the University of Coimbra has honored many scientific minds, including distinguished physicists as John Cockcroft, who paved the way for nuclear energy and nuclear applications while doing fundamental investigations in nuclear physics. In 1951, he shared the Physics Nobel Prize with Ernest Walton for their pioneering work on the transmutation of atomic nuclei by artificially accelerated atomic particles. Louis Néel, whose fundamental studies in magnetism remain essential to modern technology. For his pioneering work, he was awarded the 1970 Nobel Prize in Physics. Isidore Rabi, who laid the ground for modern magnetic resonance while investigating fundamental properties of atoms. For his discovery of the nuclear magnetic resonance, he received the Nobel Prize in Physics in 1944. Rudolf Peierls, the founder of the modern quantum theory of solids, which is key to any device in our pockets, and also crucial contributions in other areas of physics, including nuclear physics. In 1940, considering a remote hypothesis that a uranium bomb would work, Rudolf Peierls and Otto Frisch made an estimate of the critical mass of uranium-235 needed for an explosion to occur, and alerted the authorities to the results of their research. Rudolf Peierls conceived physics as a whole, whose parts interpenetrate deeply. He has been a patriarchal figure in our own school of theoretical physics in Coimbra that he has always accompanied. His disciples, João da Providência and José Dias Urbano, were the founders of this school, a school to which I'm proud to belong. And George Charpak, who, in his own words in his Nobel lecture, drew a great deal of inspiration from the work developed in the University of Coimbra in Portugal by Armando Policarpo. This work, from which I drew a great deal of inspiration, proved very valuable for the experience I gained and, more particularly, the understanding of particles governing the multiplication of electrons in gases. End of citation. Charpak then revolutionized particle detectors for fundamental studies with immense impact in subsidiary applications in other fields, such as medicine. In the cases of Dr. Piles and Dr. Charpak, this honor marked a shared history with the University of Coimbra, celebrating achievements within well-established field of knowledge. In the cases of Dr. Cockcroft, Dr. Rabi, and Dr. Neil, while building over the solid contribution of these distinguished scientists, the honoris causa degree was meant to launch the future of research in nuclear physics, atomic physics, or solid-state science in Portugal. This is now as well the case. Today, by conferring this degree upon Dr. Neven, we see it as a seed for the future, a catalyst for excellence in the growth of teaching and research in quantum computing and quantum technologies here in Coimbra. At the heart of this initiative in Coimbra lies a clear vision of interdisciplinary collaboration. It is a field that should not and must not be confined to a single department or discipline. In Coimbra, we now bring together physicists, chemists, mathematicians, computer and electrical engineers to establish and advance quantum computing and quantum technologies at this university. Quantum technologies are a strategic priority, one that Coimbra and indeed Portugal as a whole must embrace with foresight, ambition and determination. As Europe advances its digital agenda, it is imperative that we invest in people, in education, and in research ecosystems that can carry these quantum technologies forward. We also view this journey as an opportunity to build bridges within the University of Coimbra, connecting the scientific frontier to other faculties, namely medicine, pharmacy, and economics. We trust that a newly formed and highly motivated research group here in Coimbra may be seen as a promising seed, one full of potential, eager for nurturing, and ready to grow under the light of opportunity and collaboration. It is this vision and the inspiring example of Dr. Neven's work that brings us together here today. He has fostered collaboration between disciplines and mentored young scientists and engineers who will shape the next generation of discoveries. Dr. Neven's academic journey is impressive. With training in both physics and computer science, he entered the emerging field of computer vision, a field that few people understood at the time. His early work made possible technologies that now we use every day: facial recognition, object tracking, and biometric security. He also helped develop Google Lens, a tool that gives smartphones the ability to understand and interpret what they see. Thanks to this, our phones now recognize landmarks, plants, and works of art, and hopefully tell the difference between a modern heart and a coffee machine. Even in those early achievements, Dr. Neven was already thinking ahead. He was not only asking how machines perceive the world, but also how they might learn and make decisions and grow. This curiosity led him to embrace one of the most ambitious scientific projects of our time, bringing together artificial intelligence and quantum physics. At Google, he founded the now leads the Quantum Artificial Intelligence Lab, where scientists from many fields work not just to improve current technologies, but to build the foundations of a whole new kind of computing. Dr. Hartmut Neven and his team received the Physics World 2024 Breakthrough of the Year Award for a major achievement in quantum error correction. The Google team has demonstrated that increasing the number of physical qubits used to construct a logical qubit can result in an exponential reduction in the error rate. This important step brings us closer to making large-scale, reliable quantum simulations a practical reality. And then there is what is now known as Neven's law. Quantum computing power appears to grow with a doubly exponential rate relative to conventional computing. This would result of the combination of two exponential factors. In first place, quantum computers have an intrinsic exponential advantage over classical ones. In fact, the bit, the basic building block of digital information in classical computers, can only exist in two states, 0 and 1. Whereas a qubit, the corresponding basic building block of quantum computing, can represent any superposition of 0 and 1. It is this property of superposition that distinguishes the quantum computer, giving it the ability to perform calculations using a completely different paradigm to classical computer. The second factor takes into account that quantum processors are improving at an exponential rate. Neven's law is a bold and far-reaching prophecy. It suggests that quantum computing may soon enter a phase of acceleration unlike anything we have witnessed before. But today's tribute is not just about scientific milestones. It's about asking why this work matters and what it tells us about the world we are building. Artificial intelligence, once confined to the realm of science fiction, now writes text, assists doctors, composes music, analyzes data, and, on occasion, offers consolation to a scientist whose latest paper has been rejected by a reviewer. Quantum computing, once only a theory, now offers real possibilities to transform industries, medicine, energy, and much more. And still, the true meaning of Dr. Neven's work goes beyond the technical. It also carries a message, as he himself has said. It's not one company versus another, but rather humankind versus nature, or humankind with nature. This idea moves us away from competition and towards collaboration. It reminds us that science must always be driven not by rivalry, but by a shared curiosity about the universe, a shared responsibility to use knowledge wisely. At the University of Coimbra, we are proud of our long tradition of critical thinking and learning. Since its foundation in 1290, our university has always contributed to the big intellectual debates of the times. The development of spherical trigonometry by Pedro Nunes in the time of the maritime discoveries. The extraordinary philosophical systematics of the Coimbrigenses. The reform of the calendar with Clavius. The theory of plain chant with Pedro Talesio. The pioneer abolition of death penalty in 1867 with Barjona de Freitas, or the development of radiography with Henrique Teixeira Bastos and his student António Egas Muniz, who went on working on medical imagiology and won the Nobel Prize in Medicine, the first in Portugal. Our libraries hold documents that shaped nations. Our alumni include writers, leaders, innovators, and great scientists. The spirit of Coimbra lives on in every researcher that explores new ideas, in every student that dares to ask difficult questions, and in every scientist, like Dr. Neven, who challenges how we think about the future. Doutor Neven, ao aceitar este doutoramento honoris causa, torna-se parte de uma universidade que vê a ciência como um caminho para a compreensão, uma busca pela verdade e uma promessa de a partilhar com os outros. O seu trabalho em computação quântica poderá um dia ajudar a transformar os alicerces digitais da nossa sociedade. Mas hoje homenageamos algo ainda mais profundo, a imaginação que inspira o seu trabalho, a curiosidade que o impulsiona e o seu compromisso em usar o conhecimento para o bem de todos. Em nome da Faculdade de Ciências e Tecnologia e de toda a comunidade académica da Universidade de Coimbra, é com enorme prazer que lhe dou as boas-vindas à nossa família académica. Que este doutoramento sirva como tributo às suas conquistas e como uma ponte ligando o futuro da ciência aos valores intemporais desta universidade. Herzlichen Glückwünsche, Herr Dr. Hartmut Neven. Ich danke Ihnen sehr herzlich. É função da Universidade laurear quem se distingue pela inovação, pela curiosidade, por quem desafia a forma como pensamos o futuro, num diálogo com a natureza, construindo as bases de um novo tipo de computação, com a responsabilidade de utilizar o conhecimento de forma sábia. Peço, pois, magnífico reitor, que vos digneis impor as insígnias doutorais ao Dr. Hartmut Neven.
Magnífico reitor da Universidade de Coimbra, senhor representante da Presidente do Conselho Geral, senhor diretor da Faculdade de Ciências e Tecnologia, senhoras e senhores doutores, caros estudantes, restante comunidade académica, senhoras e senhores convidados e as senhoras e meus senhores. É com profundo sentido de honra e responsabilidade que tomo a palavra nesta cerimónia solene, em nome da Faculdade de Ciências e Tecnologia da Universidade de Coimbra, para prestar homenagem ao professor Dr. Paulo Marques, representante do doutorando, nesta atribuição do grau do Doutor Honoris Causa ao cientista Hartmut Neven, tão brilhantemente apresentado pela minha colega, professora Constância Previdência. A Universidade de Coimbra, fundada em 1290 pelo rei Dom Dinis, é uma das mais antigas da Europa e do mundo, mas foi em 1772, com a grande reforma pombalina, que se deu o verdadeiro ponto de viragem na sua história. O Marquês de Pombal, ministro de Dom José I, representado nestas paredes, promoveu uma reforma profunda e visionária, alinhando o ensino universitário com os ideais do iluminismo. Aboliu o domínio exclusivo da teologia e do direito, introduziu as ciências naturais como pilares da formação moderna, criou laboratórios científicos, gabinetes de física, jardins botânicos e trouxe professores estrangeiros, ao mesmo tempo que enviava docentes portugueses para se formarem nos melhores centros científicos da Europa, sobretudo em França e na Alemanha, Disciplinas como matemática, física, química, história natural passaram a ser ensinadas sistematicamente após 1772, o que lançou as fundações das futuras faculdades científicas. Foi essa reforma que lançou as bases da ciência experimental em Coimbra. As suas origens remontam diretamente à reforma pombalina. E embora a Faculdade de Ciências e Tecnologia da Universidade de Coimbra só tenha sido formalmente constituída em 1972, é a herdeira direta dessa transformação iluminista. Ao longo do século XX, em particular depois da Primeira República, essas estruturas evoluíram e foram sendo reorganizadas. A necessidade de uma estrutura dedicada ao ensino, investigação e engenharia foi discutida pela primeira vez em Conselho Escolar da Faculdade de Ciências, na década de 60. A decisão de integrar as ciências e as engenharias numa só faculdade culminou no Decreto-Lei 259/72, de 28 de julho, que criou oficialmente a FCTUC. Neste processo, destaca-se de forma incontornável a figura do professor Dr. Carlos Sá Furtado, cuja borla e capelo envergo hoje com orgulho e sentido de continuidade. Doutorado pela Universidade de Oxford, Dr. Sá Furtado foi um dos arquitetos de estrutura moderna da FCTUC, juntamente com muitos outros, que passou a incluir licenciaturas em Engenharia e, em particular, um dos fundadores do Departamento de Engenharia Eletrotécnica e de Computadores, do qual haveria de emergir, 2 décadas mais tarde, o Departamento de Engenharia Informática, liderado na altura pelo professor Dr. António Dias Figueiredo. A visão estratégica de uma elite de membros da academia, aliada à sua capacidade de execução, foram determinantes para lançar os alicerces de uma escola de engenharia e de ciências moderna, exigente e internacionalizada. Novamente se estabeleceu um plano ambicioso de formação de doutores em áreas emergentes, com o envio de jovens licenciados para centros universitários de excelência no estrangeiro, repetindo a fórmula de Pombal 2 séculos mais tarde. A FCTUC é, assim, herdeira de uma tradição de ciência e inovação, mas também de uma cultura de responsabilidade e visão estratégica. É neste espírito que hoje celebramos esta cerimónia, conscientes de que o passado nos honra, mas é o futuro que nos convoca. A FCTUC tem sido também um viveiro de talento. Muitos dos seus antigos alunos lideram hoje centros de investigação, empresas tecnológicas e instituições públicas em Portugal e no estrangeiro. Através de colaborações internacionais, a Faculdade reforça a sua presença global e oferece aos seus estudantes oportunidades únicas de formação e investigação. A sua ligação ao tecido económico e social é visível na criação do Instituto Pedro Nunes, em 1990, uma palavra de apreço muito especial para a doutora Teresa Mendes, que o geriu de 1999 até 2020, permitindo alavancar o arranque de spin-offs e startups e incubar empresas que resultam do ecossistema ensino, investigação, mundo empresarial. Desde 1995, incubou mais de 500 empresas de base tecnológica com uma taxa de sobrevivência superior a 60%. Empresas como a Critical Software, a WIT Software, a Criostaminal, a Active Space Technologies, a Take the Wind, a CleanWatts, a Perceive 3D, entretanto adquirida pelo gigante norte-americano de cirurgia artroscópica Smith & Nephew, entre tantas outras, nasceram deste ecossistema que une ensino, investigação, indústria e serviços. Das 6 maiores empresas portuguesas de software em funcionamento atualmente, 4 nasceram no universo IPN. In English, among these companies is Fidzai. Today, a Portuguese technology unicorn valued at over $1 billion, American billions, which was born from the Department of Computer Science, Informatics Engineering at FCTUC. It is one of the most notable success stories of Portuguese technology innovation. Founded in late 2008, it was born from the confluence of excellent science, entrepreneurial vision, and a deep commitment to global financial security. Isto é importante. At the heart of the foundation are 3 names. Nuno Sebastião, with a notable career at the European Space Agency, received an MBA from the London Business School, where he was considered the Entrepreneur of the Year in the technology area, a stage that he shared with Steve Wozniak and Stephen Hawking, among others. The other name, Pedro Bizarro, a PhD from the University of Wisconsin in databases and high-performance event processing. And finally, the third name, Paulo Marques, a PhD in reliable systems, particularly in mobile agents at this alma mater, with his advisor being the former rector of the university, João Gabriel Silva, who now heads IPN. Old allies from other wars, Nuno Sebastião, Pedro Bizarro, and Paul Marques served as a link between the three, which would eventually give rise to a long process of technological affirmation in cybersecurity, algorithms, supported by AI and HPC, as well as the consequent and resilient ordeal of developing a product concept and attracting the first financing and customers that allowed the company to leverage. By developing solutions based on artificial intelligence, Fidzai prevents organized crime, money laundering, or fraud, linked to several problematic contexts, such as drug trafficking, human trafficking, or arms trafficking, protecting nearly 1/8 of the world's population, 1 billion people. It processes 70 billion events per year, moving $8 trillion, the equivalent to 25% of the American GDP, or if you prefer, 30 times the Portuguese GDP. The entire North American tax system passes through Fidzai's servers. Half of the bank transactions carried out daily in the USA are also processed by the technology developed by Fidzai. These three entrepreneurs proved that it was possible to create this artificial intelligence technology from Portugal and Coimbra to the world, making it safer. The trajectory of this technology-based company is therefore impressive. In just over a decade, it became the 4th Portuguese unicorn. Its technology is now used by 10 of the 25 largest banks in the world, which attests to its relevance and reliability in the fight against financial crime in more than 190 countries. But Fidzai is more than just a successful company. It is also an example of how science produced in Portugal can generate economic value and social impact at a global scale. And, above all, it is a reflection of the culture of the innovation that Professor Paul Marques helped build at the University of Coimbra. As co-founder and CTO, he led the product development area, facing the challenges of transforming research into concrete solutions, convincing investors, and defining a business model for a product that did not exist yet. His experience, rigor, and vision were decisive for the company's growth and its international recognition. In this regard, it occurs to me that often engineers are naturally talented at inventing solutions to problems that humanity did not have, or at least did not know it had. Today, Fidzai's presence at the University of Coimbra is also a sign of a return to its roots. The company has invested in the city and the university, promoting internships, recruitment, and scientific collaboration. As a recent article rightly stated, the effect of Fidzai's investment in the University of Coimbra is already being felt. A virtuous cycle in which academia generates innovation, innovation generates companies and wealth, and companies return to investing in academia. It is in this context that Professor Paul Marques stands out. His career inseparable from the mission of FCTUC. His programming book, adopted by several higher education institutions, had a profound impact on the training of generations of computer and electrical engineers in Portugal. As a teacher, he was always recognized for his ability to inspire, challenge, and guide his students, many of whom now hold leadership positions in companies and research centers. In Tomar, where he was born, Paul Marques, while as a teenager, was influenced by his older brother, a physicist by training, to explore the world of science. From an early age, he became interested in physics, electronics, digital systems and computers, reading, like so many others of his generation, the famous textbook by Professor Eduardo Samart. He built his first telescope at home, where he also carried out chemical experiments. This self-taught and curious spirit led him to the informatics engineering course at the Faculty of Science and Technology of the University of Coimbra, where he would stand out as a researcher and later as a professor. Paul Marques' personal track record is that of a restless, curious academic passionate about science and focus on its practical application. he has always demonstrated a rare ability to combine scientific rigor with an entrepreneurial spirit. He was a professor of programming languages, artificial intelligence, and high-performance computing, and worked on cutting-edge projects such like cat detection in Edinburgh, a story that would not fit into these pages, but an example that, while curious, reveals his ability to apply knowledge to concrete problems. His career has been linked to several initiatives that have shaped science and higher education in Portugal, including the CMU Portugal program, created in 2007. This program, which brings together the Foundation for Science and Technology and Carnegie Mellon University, aims to train highly qualified professionals and foster collaborative research between Portugal and the United States. Professor Paulo Marques was involved in the initial phase of the program, namely in the certification of master's degrees aimed at business professionals. I am particularly proud to mention that I, as a professor at FCTUC, am also collaborating in this program as the advisor of PhD student in electrical and computer engineering in the area of optimization and quantum computing, Cláudio Gomes. This confluence of paths, that of the sponsor and that of the speaker, is yet another expression of the spirit of collaboration, excellence, and international vision that characterizes the Faculty of Science and Technology of the University of Coimbra. At the European Space Agency, Paulo Marques developed hardware simulators for spacecraft at the Satellite Control Center in Darmstadt, Germany, working first on processor emulation and new simulation standards, and then in the Netherlands and Rome on just-in-time compilers, graphical user interfaces, operating systems, and virtualization for operations in space contexts. He also disseminated science around the world, traveling to countries such as Timor, Mozambique, Slovenia, many others, always teaching, always sharing knowledge. He also co-founded WIT Software and Tumo. Today, he is dedicated to supporting new entrepreneurs and scientists by sharing his experience and avoiding the repetition of mistakes, thus assuming the role of a true mentor for a new generation of inventors. Today's ceremony is particularly significant. The title of Doctor Honoris Causa is awarded to scientist Hartmut Neven, Google's Vice-President of Engineering, founder and leader of the Quantum Artificial Intelligence Lab, and creator of the Neven's Law, which demonstrates the viability of quantum computing. FCTUC's proposal for this distinction highlights the high scientific merit of the doctoral candidate and his relevance to several areas of the faculty. But it goes further. This nomination is in line with the University of Coimbra's strategy of strengthening its initiative in quantum computing and creating partnerships with world leaders in the area. This commitment has been consolidated through interdisciplinary projects involving researchers in Coimbra, such as professors Helena Alberto, Jorge Lobo, Sagar Pratapsi, Ana Morgado, Nuno Batista, Oscar Ferraz, Constância Providência, Penoso Machado, Luís Macedo, Edmundo Monteiro, Vítor Silva, Marco Gomes, André Perrota, Licínio Roques, Marília Curado, and myself, among others, and which have placed the University of Coimbra on the international map of applied quantum computing, as shown by the poster session of yesterday's workshop. A notable example is the selection of FCTUC team for the final of the Blaise Pascal Quantum Challenge, promoted by the French neutral atoms company Pascal. Among more than 150 teams from 70 countries, the University of Coimbra was the only Portuguese institution to achieve this distinction. The project, presented and funded by CERN in Switzerland, focuses on the development of quantum artificial intelligence algorithms for medical imaging by exploring quantum reservoir computing. This work, which combines electrical and computer engineering, computer science, physics, and biomedicine, is a clear example of FCTUC's interdisciplinary vision and commitment to cutting-edge science and the creation of solutions with social impact. The presence of Hartmut Neven at this ceremony and the choice of Paulo Marques as the presenter symbolize this bridge between academia and industry, between fundamental science and its transformative application. Both represent the best there is at the intersection of knowledge and innovation. Ao homenagearmos hoje Paulo Marques, é inevitável recordar o percurso de outros visionários que, ao longo da história, moldaram o mundo através da ciência e da tecnologia. Como nos recorda Walter Isaacson na sua obra Os Inovadores, a revolução digital não foi obra de um só gênio isolado, mas de uma constelação de mentes criativas que souberam colaborar, arriscar e transformar ideias em realidade. Desde Ada Lovelace, que no século XIX antecipou o conceito de programação e algoritmo, passando por Alan Turing, que um século mais tarde lançou as bases da computação moderna, ou Grace Hopper, pioneira na criação de linguagens de programação dos primeiros compiladores, ou Robert Noyce, co-inventor do microchip, juntamente com Jack Kilby, até Tim Berners-Lee, criador do World Wide Web, entre outros, todos partilharam uma característica essencial, a capacidade de imaginar o que ainda não existia e de trabalhar em equipa para o concretizar. Estes nomes representam marcos na evolução tecnológica. O transistor, que permitiu miniaturizar circuitos e democratizar o acesso à eletrónica, o microprocessador, que deu origem ao computador pessoal, a internet que interligou o mundo, a web, que transformou radicalmente a forma como comunicamos, aprendemos e trabalhamos. Cada uma destas inovações foi possível graças a uma combinação de conhecimento científico, visão prática e espírito colaborativo. Mas há também uma dimensão mais subtil, e por vezes esquecida, que atravessa a história da ciência, a da sensibilidade artística. A própria Ada Lovelace, que era filha de Lord Byron, poeta romântico por excelência, talvez por esse motivo tenha sido capaz de ver na máquina analítica de Sir Babbage não apenas um instrumento de cálculo, mas uma máquina igualmente capaz de criar música e arte. Essa instituição de que a ciência e a arte não são domínios opostos, mas antes complementares, é também visível em figuras como António Gedeão, o pseudónimo literário do cientista português Rómulo de Carvalho, que nos ensinou em verso que o mundo sonho comanda a vida e sempre que o homem sonha o mundo pula e avança. É, pois, profundamente simbólico que em Coimbra existe o Centro Rómulo de Carvalho, um espaço dedicado à divulgação científica, à curiosidade intelectual e ao cruzamento entre ciência, cultura e cidadania, fundado pelo professor Carlos Filhais e atualmente dirigido pela professora Constância Providência, oradora do homenageado. Um centro que honra o legado de um homem que foi simultaneamente físico, professor, poeta e humanista, e que nos recorda que a ciência, quando se abre à arte, torna-se mais próxima, mais humana, mais transformadora. Vou terminar. Paulo Marques inscreve-se nessa linhagem de inovadores que não se limitam a resolver problemas técnicos, mas que sonham com o que ainda não existe. Tal como os protagonistas da Revolução Digital, também ele soube cruzar ciência e engenharia, academia e indústria, visão e execução. A sua trajetória, que parte da curiosidade de um jovem em tomar e culmina na cofundação de uma empresa global como a Fidzai, é um testemunho vivo de como a inteligência, a verdadeira inteligência, a que comanda, nunca será artificial, de como a ética pode dominar a visão de negócio e de como a visão e o conhecimento, quando aliados à coragem e à colaboração, podem transformar o mundo. Gerhard Tuff, o Prémio Nobel da Física, dizia que nesta fase não é importante tentarmos dar resposta a perguntas antigas, é mais importante tentarmos encontrar novas perguntas para os problemas que temos em mão. O padrinho, tal como candidato a este grau, materializam duas dimensões, a academia e a indústria, estabelecendo pontes, envergando de forma espontânea e natural a figura de mentores e visionários numa trajetória instigadora. É, pois, com orgulho e emoção que presto, e, creio, toda a academia comigo, esta homenagem ao cientista Paulo Marques, convicto de que o seu legado continuará a inspirar gerações futuras. Ao encerrar a minha intervenção, permitam-me partilhar uma citação de Stephen Hawking, que Paulo Marques tantas vezes evoca. The rise of AI could be the worst or the best thing that has happened for mankind. We simply need to be aware of the dangers, identify them, employ the best possible practice and management, and prepare for its consequences well in advance. Muito obrigado.
Quid petis?
Gradum doctoratus in praeclara scientiarum et technologia facultate.
Ego, Amílcar Celta Falcão Ramos Ferreira, cujus almae universiensis Academia Rector, perat doctorem praeclarae scientiarum et technologia facultate, in nomine et autoritate ejudens Academia. E comito clarissimo domino Dr. Edmunus et de Silva Monteiro, patrono tuo ut insignis doctoralibus decorre.
nunc res mihi agere gratias pro tot tantisque beneficiis erga me collatis.